Hello and welcome. My name is Caio and I'm an engineer at Typhoon Hill. In this video, you'll be focusing on the new features and improvements included in 2025.1 software release for Typhoon Hill. Join us as we explore more details of what this release has to offer. One of the major changes in this release is the new mask editor, which now features a "what you see is what you get" interface. This makes designing and modifying component masks more intuitive and dynamic. You can now drag and drop widgets and tabs, as well as edit labels, units, and tab names inline for a smoother workflow. New layout widgets such as the section widget and empty widget provide better organization within the mask. Additionally, property descriptions and context-based attributes are now integrated directly into the interface, improving the clarity. Another feature is the matrix editor, which is used for editing vector type properties. This tool helps you visualize and modify lists or nested lists of values more effectively. A major addition is the preview button, which enables quick testing of dialog dynamics handlers and provides an instant view of any modifications before applying them. The Handlers tab has also been revamped to support all mask handlers with a drag and drop functionality from both the containers list and namespace list, streamlining property editing. For those who want a deeper dive, a separate tutorial video is available that demonstrates all these features in more detail. If you are looking for a hands-on guide, be sure to check it out. With the new additions to our Ethernet communication library, you can now implement custom protocols based on TCP and UDP, allowing them to run seamlessly on the Hill device. This flexibility brings added benefits of enhanced fault tolerance, improved debugging capabilities when working with your custom protocols, and more. Both protocols run as bare metal applications with a guaranteed deterministic execution rate and are available on all Hill devices. These relevant components can be found under Communication, Ethernet Communication in the schematic editor. For those looking for a detailed walkthrough of these components, we have prepared a dedicated tutorial video which covers them in more depth and demonstrates their practical use. The Automotive Communication Extender is a modular Hill Connect card designed to support various protocols used in automotive applications, including CAN, CAN-FD, LIN, CENT, SPI, and FlexRay. With this release, we've introduced software support for managing SPI communication via your ACE card through the new SPI Setup component. The SPI Setup can be found under Hill Interfaces within the Automotive Communication Extender Library category, and is used to configure the SPI controller settings for the selected AC card. Additionally, firmware updates for the ACE card are now supported through Typhoon Hill Control Center software and can be performed directly via Ethernet connection. To access the ACE firmware update tool, simply navigate to the Update ACE Firmware button in the device manager. With these updates, we aim to offer a more convenient and streamlined experience when using the ACE card in your automotive applications. This release introduced two new important electrical components. The first one is the three-phase permanent magnet synchronous machine, ANSYS ECE, which allows for the direct importing of electrical parameters in the form of lookup tables from ANSYS Maxwell. To access it, you can navigate to the Synchronous Machine Library section of the Machines library. After deriving machine parameters from ANSYS Maxwell using the equivalent circuit extraction method, you can easily import them and apply them to this machine model in the form of a .txt file, by selecting its path in the Electrical tab of the component. The ability to integrate with ANSYS software allows for more accurate modeling of the PMSM and ensures better correlation between simulated and real-world machine characteristics. The second component is the phase-shifted full-bridge converter, a ready-to-use DC-DC converter block designed for high-frequency power conversion applications. A key feature of this converter is its reliance on the switch-level oversampling mechanism, which makes it suitable for real-world switching frequency requirements. Following the familiar property design pattern of our converter blocks, you can choose between different control modes such as digital inputs and the internal modulator in the General tab, and define its electrical parameters in the Electrical tab. These new components enhance the versatility and accuracy of your real-time simulations, enabling better performance in the domain of electrical machines and power conversion systems. This release, like many before it, includes updates to our existing communication interfaces. The first update pertains to our serial communication capabilities, where we've enabled serial communication over digital I/O pins, allowing them to function as serial communication ports. This feature is supported on all active devices. Digital inputs can now be configured as RX ports through the serial setup block, while digital output can be set as TX ports via the output settings component in Schematic Editor or the digital output section of the model settings dock in HuSCADA. The second update focuses on our time synchronization capabilities. We've added the ability to retrieve the current UTC time directly from the time synchronization component. Additionally, a timestamp to date time converter has been introduced, enabling you to convert an input UTP timestamp into a human-readable date. With these updates, we aim to support your time-based logging and distributed system synchronization needs. This release also brings performance improvements that enhance overall simulation efficiency. By implementing cache coherent data transfers between CPU cores are less burdened and inter-CPU communication latency is reduced, resulting in a lower time slot utilization. This is especially evident when running models on multiple user CPU cores, as well as models with a lot of SCADA inputs and probes. Another optimization is faster user library loading. The introduction of per-file caching for schematic editor libraries reduces loading times, benefiting users who work with large and complex user libraries. We hope these changes will enhance your workflow, delivering a smoother experience through improved performance. Finally, let's talk about the newest Typhoon Scene updates. With this release, the Package Manager and Signal Analyzer tools are now available in the standalone version of Typhoon Scene. These features allow you to install custom packages and perform post-inspection of captured signals, respectively. Library support has been expanded to include previously unavailable machine models, 4 new converters, and the fuel cell component. Additionally, you can now calculate losses for MOSFET switches, enhancing the accuracy of your simulations. Finally, signal processing validation has been relaxed, so execution rates no longer need to be a multiple of the fastest rate. Plus, there is no longer a limit on the number of different execution rates, offering you even more flexibility in signal processing modeling. Thank you for joining us on this release walkthrough of our 2025.1 software release. We invite you to test out these new features in your project and provide us with your insights and experience. For more information and updates, stay connected. Thank you for watching.
Check the video description for more resources on this topic, including how to download and get started with Typhoon Hill Control Center for free. You can also visit Hill.Academy to access free courses, expand your Hill testing skill set, and get certified. Subscribe to our channel to get notified about new content.